Okay, now we're going to do the inequalities section for the compound inequalities that are or inequalities, not and, but or. So this is another special kind of inequality, a compound inequality. And the or statements, you can think about if one or the other is true, we're going to graph it. It's going to be part of our solution set. With the and ones, it had to be in both of the graphs to be a part of the final solution. This one's not as strict. It can be one, it can be in one, or it can be in the other. And there's the word or. So again, we're going to do just like we did before. 3 is the bigger number. 0 is our smaller number. We want all the numbers less than 3 going this way. We want to graph all the numbers greater than 0 going this way. And now our solution graph is going to look different because it is going to include all of the points that are in this graph or are in this graph. And that pretty much covers it. That's the whole number line. If you start at 3, if you start at 0 with an open circle, you're going to pick up this 3 right here as this guy is going on to infinity. And in this one, you're going to pick up the point 0 as this guy is headed toward negative infinity. So our answer is really going to be the entire number line, which includes all real numbers. So I cannot draw this very well, but you guys can do a better job. So we're going to shade in all of the numbers on the number line, and the way we write that mathematically is with a funky looking backwards R that stands for all real numbers. Let's look at example number 2. Again, our target numbers are 2 and 2. Okay. There are all the numbers that are greater than 2. And you notice that these are the same numbers that we used on the and equations to show you the difference of what your actual answer, how the graphs are going to look different if it's an or an and compound inequality. This is 2. This is also 2. We want all the numbers less than 2. And our graph is going to say we want all of the numbers greater than 2 and all of the numbers less than 2. So the only point on the number line that doesn't satisfy either one or the other of those equations is the point 2 itself, because neither one of these equations had 2 in their graph. So we're going to draw it like that, and it's going to include all numbers, and we could say all real numbers except x cannot be equal to 2. Let's look at example C. Again, our target numbers are -3 and 2, so I'm going to write the -3 here and the 2 here. And then I'm going to go graph all the numbers less than -3, and you guys can see this goes pretty quickly. Greater than 2. This is an or equation, so it can be in one graph or it can be in the other graph. So that includes all of the points going this way from 2. And it also includes all of the points going this way from -3. And there's not a fancy way to write this. This is really the way we write it when you have an or situation. Last example on this page. 4 and 1 are my target numbers, so I'll write them chronologically. This graph is less than 4, going that way. This graph is less than 1, going that way. And all of the numbers that are in one or the other of the graph is what we're going to put on our answer graph. So that is going to include everything that's less than 4, because that picks up all the numbers that are less than 1 also. So there's the word or, and that takes care of the second type of compound inequalities. So tune in for the next video. We're not quite done with 3B. I've got at least one more video. Bye.